It's spring, the sun is hot, and I just finished drinking a can of ginger ale. Wow, that tastes good. But have you ever wondered why companies design their containers the way they do? To find the answer to this, we need to explore optimum volume and surface area. But what does optimum mean? Mathematically, it refers to finding the best of all possible solutions to solve a given problem. Think about optimistic people. They always aim for the best. So optimism equals best. Let's see how optimum volume works.
Abla and Kwame are making a square-based prism and cylinder, each using 600 centimeters squared of material. The question is, which one has a bigger volume?
It's the cylinder.
No, it's the square-based prism.
It's obviously the cylinder.
It's the square-based Stop! Prism. There's only one way to find out. Maximize the shapes and then compare their optimum volumes.
What does that mean?
Yeah, what does that mean?
Let's take the square-based prism. We've been taught that volume is length times width times height, but here's another approach. Square the side length and multiply the height to get the volume. Trust me, it'll help us later. Okay, we know the formula for volume, but what is the optimum volume? If we table out some possible measurements, the optimum volume is the largest volume. Transferring to a graph, the peak is always the most optimum. This graph is called a parabola and its peak is called the vertex. Same procedure for the cylinder. It will end up in decimals because of the never-ending pi, but it all comes down to the same idea. Since we wanted a larger volume, the cylinder is the winner. But we can't be drawing tables and graphs all the time. There must be an easier way. There is! Look at their base numbers. For the prism, it was all 10 centimeters, meaning that a perfect cube had the optimal volume. And for the cylinder, this was achieved when the height was twice the radius. To understand this better, we have a cube, cylinder, and grain. They both have the same surface areas, but maximizing their volumes give the cylinder a huge advantage. Now let's focus on optimal surface area. Abla is using 64,000 centimeter cubes of ice to build her very own ice sculpture. Using the same shapes, which one is better considering the less surface area the sculpture has, the more slowly it will melt? Now that we know the trick already, we are only focusing on a cube and a cylinder which height is twice the radius. Again, the cylinder won with the optimal surface area. But why? It gets a little complicated, but in simple terms, the optimal cylinder has more volume per surface area and beats the perfect cube by about 0.128 cubic units. So here's the answer to the question that started this video off. Companies design their containers the way they do because their main goal is to have the greatest volume with the least surface area. Almost all products are in can shaped like cylinders. Because reduced material saves the environment, they are easier to put labels on. Cylinders appear to consumers as a great value for their money. But optimal cylinders will save the company money by using less material to put in the same product.